In this video, we will talk about regular expressions or regex. Regex is an incredibly powerful tool for searching, manipulating, and validating text. Regex is a language agnostic, meaning you can use it in Python, in Java, and now you can even use it in Excel. If you're new to this channel, I'm Karina. I have been in data analytics and data science for over 10 years, and now I share my knowledge with other people online. So why regex is useful? It can be used to validate inputs, for example, email addresses or phone numbers. You can even use it in Google and Microsoft Forms when you're collecting data and you want to make sure that data follows a specific pattern. For example, phone number starts with plus sign and has a specific number of digits. Regex can be used to extract a specific data from a large data set. For example, you know the specific domain and you want to extract all email addresses with that domain. Or you want to extract all information that contains an address. So you know that it can have a boulevard, a street, an avenue. You want to extract all the data which is an address. Regex is also used to search and replace text and for text cleaning and pre-processing when you use a machine learning. Now let's have a look at examples of regex in Python, and as I mentioned before, the pattern can be also used in Java and in Excel. The module or library to work with regex called RE or regular expression, and the first step, you need to install this module on your machine, and to do that we say exclamation mark pip install re, run this script, and after that we need to import re. So we say import re, let's run it, and now we have this module in our environment. Here is a list of basic functions in regex. So we have re.search where you indicate pattern and then a string. .search helps us to find the very first match in all your dataset. In case you want to find all matches, for example, all email addresses containing a specific domain, you want to use find all instead. So we say re.findAll, then you indicate a pattern, comma, a string or comma text where you're looking for it, and it will return you all matches. The next one is .sub. It replaces matches. So it finds a pattern and then you say how to replace it, and a string is where to find this specific pattern. And .compile helps us to compile a regex pattern for reuse. When you work with a very long pattern, you might want to split it or do it step by step, and then you use .compile to create this huge pattern reusable in your code. The first thing, we need some text that we will be working with. For example, we will create this one. We create a text and we will say hello Python. Then we need to indicate what is our pattern, and the very first pattern we will be working with, we want to find the word Python in the text, and we want to find it exactly this way with capital P. In this case, we will use .search. So we are creating a new variable called result. Result equals re.search. In the brackets, we say pattern, comma, text. And to view our result, we will print it. We will say print brackets. In the brackets, we say result.group empty brackets. Let's run it. And you see that our regex find the word Python. Let's quickly talk about special characters. If we use dot, we want to match any type of character except for new line. If we use \d, we indicating that we want to match any digit from 0 to 9. If we use \w, we match any word character. And it's not only a letter, it can be also digits or underscores. And \s is spaces or white spaces, tabs, new lines. So you noticed we have this backslash before our d, w, and s. So we use a backslash because we want to escape a special character. If we just use dot, it will match any character except new line. But if you want to find a dot, for example in .com, you need to use backslash before the dot. So you need to indicate to the programming language that no, it is a dot, not a special character, but a dot, just a character. So similar with W, D, and S. So if you just use D, the computer will think that you are looking for a D or W or S as a letter. But you want to indicate that no, I'm not looking for a W as a letter, I'm looking for any word character. In that case, we use this backslash. So backslash is used to escape a special characters. And for the same reason, we need to use a raw string. So when we use a raw string, we use a small letter R before our pattern, and you will see we will be using it now. So if you don't use a raw string, Python interprets the backslashes first as an escape characters. When you use a raw string, you ensure that backslashes are treated literally and not as escape characters. If you don't want to use a raw string, unfortunately, you will have to use extra backslash, and then your pattern will just turn into the beast that has double backslashes everywhere. It's very confusing, and let me show you what I mean. So for example, we will create a new pattern where we say a raw string, and to indicate that it is a raw string, we use this R. And then quotes, you can use single quotes or double quotes, it's up to you. Then we use \d to match any digit, plus we will get to in a second, and then our text will be 1, 2, 3, ABC, and we want to find this pattern. And let's run it, and you can see that we found this 1, 2, 3 in our text because we were looking for any digits. Now we need to talk about quantifiers, or how we control how many times a pattern repeats. When you use a star, it indicates that the pattern might repeat 0 or more times. It can be there once, 5 times, or not be there at all. In case you use plus sign, then you say that it will be there at least once or more times. So when we look back, we say there would be at least 1 digit, or can be more. So it can be once, twice, 3, 15 times, we don't know, but at least once. That's why after D we used plus. If we use a question mark, we say 0 or 1 time. So it can be there or not, but not more than once. And if you want to indicate exactly how many times the pattern will repeat, we need to use curly brackets, and in curly brackets you indicate a number of times with n. And if you want to indicate between n and m times, again you use curly brackets, and then you indicate n, m. Now let's have a look how to match phone numbers in the text. For example, we have this text saying call me at this phone number or the next phone number, and let's create our pattern. As I mentioned before, we need to use a raw string, so we use R, and after R you use either double quotes or single quotes. It is up to you. I will use double quotes, same as in my text. So what are we looking for? We are looking for digits or numbers. That's why we say \d. We know the pattern. In this case, we see that our pattern is 3 digits, then hyphen, 3 digits, hyphen, 4 digits, and it's similar in both phone numbers. In that case, we are looking for digit, and we know for sure how many times it will repeat. It will repeat 3 times. That's why we create our curly brackets. In curly brackets, we say number 3. After that, we know there would be a hyphen, so we use hyphen. After hyphen, we have another 3 digits. So again, \d, curly bracket, 3. After that, hyphen, \d, but this time it will repeat 4 times. And that's it. This is our pattern. Now we're creating the variable match equals re.findAll brackets. In the brackets, we indicate the pattern and then text. And now we want to print our match. So let's run it, and you can see that we found both phone numbers that follow the pattern we indicated by 3 digits, hyphen, 3 digits, hyphen, 4 digits. In case you don't know how many digits, this is where you start creating various patterns, and you say it can be this way or that way, it can have hyphen or not. Let's talk about groups of characters to match. In square brackets, we indicate what characters we want to match. For example, we want to match characters A, B, C. That's why we use square brackets. And then we say that we want to match any of those characters. In case you use square brackets and you say A hyphen Z, or basically from A to Z, it matches any lowercase letters. In this case, we used lowercase. In case you want to match all uppercase, in that case, we use a different pattern. It will be square brackets and then capital A to capital Z. So that will match any uppercase letter. If you want to match any digit, you say square brackets 0 to 9 and matches anything except for ABC. In that case, you use again your square brackets, but you use this hat sign, which called caret or caret. I don't know how to properly pronounce it. And this hat sign says anything but or except. We will have a text called Python is great, and let's create a pattern, and a pattern will be, again, you start with a raw string, then double quotes, and we want to indicate that our letters or this pattern will start with uppercase letter. You see we have Python and grade that have a capital letter first, so we will say it starts with capital letter, and then in square brackets we say A to Z, and then we use a star. You remember that star means 0 or more times. We don't know if this pattern exists at all or if it exists 100 times, so that's why we use a star. And then we again use our match, and we want to print our match, and it returned Python and a grade. And if you look back at our text, we also had a dot which was ignored because we were looking for groups of characters or words, so we were not looking for a dot or any other special character. And we also said that it must start with a capital letter. So for example, we have is, and it was ignored. So you can see how it can be used to clean your text. For example, when you want to remove all special characters, so you want to look only for words, and this way you just find all possible words and all special characters are left behind. Other thing we need to discuss is anchors, or the way we can specify position in our text. If we use our caret sign, and you've seen it before, it matches the start of the string. If it's used in a square brackets, it indicates except for, but if it's just used on its own, it matches the start of a string. And if you use a $sign, it indicates that it is end of the string. Let's create another text, a famous hello world, and my pattern will start with the word hello. We use R, we use double quotes, then we use the head sign, then we say hello, and then we again need our match and print match. I will just copy it, let's run it, and you can see we matched hello. Now let's have a look how we can use what we've learned for email search. For example, we have this text this is a list of email addresses, and we have different types of addresses, and you can see some of them have some mistake, others finish with .com, some finishes with .co.uk. Now we are creating our pattern, so we say R, and then we use quotes. In quotes, we know that our domain name always starts with at least one character, so we are creating a group, and then in our group we are looking for any letter, any digit, any underscore. To indicate that, we use \W, so we know that backslash means any letter, digits or underscores. We know that we can also have dots in our names, that's why we use \dot. We can have underscores, but underscores are already included in this \W. And we can also have hyphen, that's why we will add hyphen. So we say that before @sign in our domain name, we can have any letter, any digit, underscore, dot or hyphen. And how many times this pattern repeats? It can be one or more times. For example, this one is invalid because before @sign we have nothing, which is impossible. It must be at least one character. When we want to say at least one or more times, we use plus, because when we use star, it means 0 or more times, but we want to say at least once, so we use a plus sign. After plus sign, we know for sure we will have @sign, because every domain name has @sign, and after that we will have again a group of characters similar to what we had before our @sign. We will have it after @sign, so it will be \W, again \dot, and it can be a hyphen. And how many times? One or more, that's why we can use plus. After that, we know for sure we will have a dot to indicate .com, .org, that's why we use \dot. After \dot, we again will have some word or letter, that's why \W, and how many times? One or more, or we using plus. And let's match this pattern. And you see we found 2 email addresses that are valid, that follow our pattern, which was something before @sign, then @sign, then the domain name that has at least one dot to match this .com, .co.uk. Now let's use our knowledge to match URLs. For example, you have a text which contains different URLs, and you can see some of them starts with HTTPS, others starts with HTTP, some of them have www at the beginning, others don't. So how to create a pattern that captures all of them and extracts all of them? So let's create our pattern. Again, don't forget our raw string and then quotes. If you don't use raw string, so how it will look like, usually we use this \d, for example. In that case, it needs to be double D. So imagine the pattern that we've just created for email addresses. Without raw string, you have to add double backslash to every single slash you're using. So your pattern will look like this, and you can see how more complicated this code looks, how hard it is to read. That's why my advice is to always use raw string. Okay, let's go back to creating our pattern for our URLs. So we know that it will start with HTTP or HTTPS. That's why we say HTTP, then we say S, and we add question mark. Question mark means that it will be 0 or 1 time. So it can have this S or it might not have. So we say that our pattern might contain this S or might not contain this S. Question mark is related not to all the characters, but one character. So remember, when we say a group of characters, we take them in square brackets like this. But if you don't use the square brackets, you're referring to every single character one by one. So this question mark is related to S, is not related to HTTP. After that, we always have double backslashes, so it's always the same pattern. When you use brackets, you indicate what exactly from your pattern you want to capture. For example, if you look back at our email addresses, maybe we wanted just to capture domain names or everything that was before the @ In that case, we needed to use just ordinary brackets to indicate what specific group of characters we want to capture. For example, we want to capture only everything before @. In that case, we should have used ordinary brackets around this first part. Let me show you how it works. You see, in that case, we capture not the whole email address, but only the part that is in the brackets. Or you wanted to capture only the domain names. Let's create brackets around everything that is after @. Let's rerun it. And you see, we captured the domain name, which sometimes also the task. So you want to find email address, and then from email address, you only want to capture domain, or you want to capture username, or you want to capture both, but separate them in two separate columns. So you create username equals pattern match 1, and the domain, it will be match group 2 in that case. We use ordinary brackets to tell Regex what exactly we want to capture. We will use ordinary brackets here to indicate that we don't want to capture this www, question mark, and then colon. This way we indicate that it is a non-capturing group. So whatever happens in these brackets, if we match it, we don't want to capture it. Then we are looking for www, and this www ends with a dot. That's why we say \dot, and we use question mark at the end of the group to indicate it happens once, or it might not happen at all, so 0 or 1 time. After that, we are looking for a word, so we use a square brackets as we used it with our email addresses to indicate this sequence of characters. So again, it can be a letter, it can be digit, underscore, so we will use our \w as we've done before. Again, it can be a dot, so similar to this one, we will use again our \dot, and we will use hyphen. How many times can it happen? It can happen once or more times. That's why we use our plus sign. After plus sign, we know for sure there would be a dot, and again we use \dot, and after that it can be characters, digits, underscore, or our favorite \w, and how many times? As many as it can be. That's why plus sign. And we definitely need to close our raw string. Let's copy these 2 lines of code and run it. And let me show the difference if we remove this question mark and colon before our www, what would have happened. Let's rerun it. So you can see what happened. So this captured only www dot part because it's inside of a capturing group, leaving the full URL out. While we wanted the full URL, this question mark and colon affects grouping but doesn't influence what dot find all matches. If you use the capturing group instead, like we've just done, you can see that find all would have returned only the part matched by the capturing group and omitted the rest. So we want to avoid that, and because of that, here we use this question mark and colon. Let's rerun again, and you can see it returned us full URLs. And let's have a look at one more thing. For example, we have a text that has different addresses, and you want to find all the businesses that are located at the George Street. So this is the text, and let's create a pattern. As always, we start with a raw string, and then we will use a \b, which you haven't seen before. So \b is a word boundary anchor. It doesn't match any actual characters. Instead, it asserts a position in the string where a word boundary occurs. So we know that our address will start with George. That's why we say this \b, then George, then a space, it will be st, and then again \b. So we say that it must contain this George Street and spelled this way with actually lowercase s. Then we use dot star and question mark. So dot is matches any single character except of new line. Our star matches 0 or more occurrences of the preceding element. So in this case it is dot. So we say that dot might be there, might not be there, how many times we don't know, while question mark, it makes our star lazy, meaning it matches as few characters as possible while still allowing the entire regex to match. So in fact, it matches the smallest amount of text after George Street up to the next part of the pattern. After that, we know there must be a digit, and to indicate a digit, we use \d. We want to say how many times it can be. And remember, if you know exactly how many times, we can use it in curly brackets, but if we say it can be once or 5 times, we use again curly brackets to indicate between n and m times. So we use our curly brackets and we say from 1 to 5 times, and we indicate the boundary. Copy this and print it. So you can see we extracted all George Street. But let me make some changes here. And for example, I will add a unit. Let's run it. You can see that unit 1 to 3 is not included. This \b is the final word boundary, ensures that the match for the numeric value, preventing it from including extra digits or characters. So we're indicating what we want to capture, where we should stop with our pattern. And for example, if you wanted to capture unit, then we needed to modify our pattern. We need to add this brackets, question mark and a colon. We start with \s, meaning white spaces, how many times, as many as possible. Then we have a unit, then again white space, as many times as possible, and then a digit 1 or more. And if we rerun it, we capture the whole string, including unit. I will save this workbook to my data playbook. If you sign up to my free newsletter, you immediately get access to different free resources. There are links to various books, there are templates, roadmaps, there are some workbooks, and I will add this workbook there as well once this video is live, so you can use this workbook as your little cheat sheet. Hope you enjoyed it, and I hope to see you next time.